Everyone, this is Carter with first updates now at the Michigan State Championship. Today I'm with 5907, the CC Shambots. We're going to check out their robot, their under the bumper intake, their shooter, double-sided climber, and their awesome vision system. All this and more on this episode of Behind the Bumpers.
This video on fun is brought to you by viewers like you and also in partnership with the following. AndyMark is your one-stop shop for all your robotics competition needs. Celebrating 20 years of quality robotics parts and superior service, AndyMark employees have over 200 years of first-team experience. From mechanical and electrical products to tools and hardware, head on over to AndyMark.com for high-quality and affordable solutions. Support Fun's content creators when you sign up for a membership on YouTube Join. You'll get access to special perks like emotes, loyalty badges, and Fun members will even get early access to our scheduled videos and more. 100% of this revenue will go back to our correspondents to help recognize their efforts. Click the Join button in any YouTube video to pledge your support.
All right, Aiden, can we go through the intake and the transfer system? Start going through the note path for me.
Yeah, sure. So, first of all, we have the under the bumper intake. It uses 1-inch polycarb rollers, and we wrap them with this surgical tubing material. We got it off of McMaster Car, I think. So we just wrapped it with that, and it goes straight under the bumper. Do you know how much compression we have? We have 0.25 inches of compression on the ring through the path. These are on a 1-to-1 with Krakens right now, and then we have a limelight that detects the note and will auto track to it. So it starts there. Initially, we had belts on this, and it wasn't very good, and our compression was lower, I think. We had less compression, and then we went to, we had a bunch of these as well, but they were slipping on the shafts and stuff. We had a bunch of 3D printed pulleys and things like that, but they were slipping, so we switched to all these aluminum pulleys and the rollers, and we marked forged our hubs, our hex hubs that go into the polycarb rollers, and that seemed to solve our issue. But this has been super solid throughout our competition. And then it goes up into our indexer, which is this part of the shooter. This is all one thing, so it's controlled by just one motor. I don't know if we can get that open there, but so basically we have 3 prox sensors on here, and it will pull the note up until this prox sensor and this prox sensor are triggered, and this last one up here isn't. So it'll hold it in spot. It gets it in the same exact place every single time, so that the shots are reliable. We have these extra wheels in here so that it can catch the note in some weird spots that we've had issues with in the past. And then these polyurethane belts. These are actually pretty slippery, but it helps let the ring pass through easier for the flywheels, so that it's easier for the flywheels to take control. And then we have these 2-inch green flex wheels that we cut the sides off of to get more grip on the ring. And it seems to feed it more consistently for us as well. And the indexer is also on a Kraken, so we get a little bit more torque. Yeah, that's pretty much the whole thing.
Awesome. Now, can we move over to the shooter and the climber mechanism?
Yeah, so first, as you can see with the flywheels here, we actually have 2 different types of wheels on here. We have some black stealth wheels here and green flex wheels here. The main reason we got that going on is because we actually found that spinning at the high speeds that the flywheels need to spin, they actually expand about a quarter of an inch? Yeah. About a quarter of an inch. So they grow, but the stealth wheels do not. So actually the ring grabs against these flex wheels first, and later on with the stealth wheels, giving it spin on the way out without having any sort of differential between the flywheels. It's just a natural spin that comes out as soon as it leaves the flywheel. And then also, as you can kind of see here, the LED chasing lights, they're status indicators for our robot. It helps the drive team out. It tells the status of the robot if something went wrong, if the note has been intaked correctly, if it's ready to fire or not, especially with working with the targeting system. Something unique that we got going on is for amp, actually, we don't have a separate mechanism. We just use the flywheels that we have already, and they actually spin at different opposing speeds, and it just kind of slots it in.
Okay.
It's a way to do it without increasing complexity, and it is quite reliable. At our Livonia competition, it worked almost 90% of the time, pretty much. I mean, it was driver error if it didn't work. And then moving on to the climbers, we have some telescoping climbers, in part made with COTS products, the West Coast products, doing all this stuff here. But we have dual climbers in order to increase reliability when climbing on the chain. And specifically, we got the hooks here. They have a little slot in there, actually self-centers. Self-centers the chain when it climbs, when it winches down. And as you can see down here, the gearbox for the climber is a 30-to-1. So when at the end of the match, when it's climbed, it slowly lets itself down, so it can actually stay up without power, using the brake mode of the motors. And specifically with those, in order to decrease slop, we have shimmed the gears. It increases responsiveness, and it helps us to be more reliable in knowing where exactly our mechanisms are when they're going through their operations. And then finally, you can see this little 3D printed bracket that comes down. It's kind of a quality of life improvement for us. We had problems, or it was just difficulties taking it off the chain at the end of matches because we were afraid we'd lose where they were, so we couldn't zero them correctly at the end. So actually limit switches down here that when triggered, it tells the robot that the climbers have reached their 0 point, so we can mess with it, and we know that we'll always arrive at a reliable 0 point at the end anyway.
All right, mechanically absolutely gorgeous. Let's move over to the software side of things. Tell me specifically about your vision system. It looks like you have 4 cameras on either side of the robot.
Of course, yeah. So we actually have 5 cameras total. 4 of them we use for the AprilTag tracking, but I'll mention the Limelight one first. So as Aiden quickly glanced over, we have a Limelight 3 on the bot running with a Google Coral, running the default neural network that Limelight trained this year to be able to very reliably detect the notes and then pick them up, which has been awesome for us in auto. You see a lot of teams coming out to the midline just being a little bit off one way or the other. So instead of running a straight path just out there, we actually give control up to our Limelight at the end point of our paths, which has greatly increased reliability on hitting pickups successfully. And then moving on over to the AprilTag cameras, we have 1 on each corner that we added for various different reasons. One of them is face up significantly. This top right corner one, or front right corner, is angled up significantly to give us the closer range vision of the speaker and the amp specifically. It's angled up so that we can see the amp tag almost the whole time while we get close to the amp. And then the other ones are angled at a less steep angle so that we can see tags from much farther away. So the point of all that is to, using photon vision, we detect where the camera is relative to the AprilTag, and then using measurements that we get from CAD, we know where the camera is relative to the robot, which allows us to extract the robot's position. So in total, we integrate our wheel data, our gyro data, and then data from up to 4 cameras providing pose estimates to estimate where we are in the field at any given time. Which has been super helpful, especially we've had matches where we've broken a camera or something, and for a lot of teams that might be a critical fault, but because we have so many, there's redundancy and a lot more reliability with that. And one thing we just recently enabled was multi-tag on the Photon Vision. It's super easy to swap which mode you're using, and we realized we weren't using multi-tag up to this point, and that greatly increased the stability of our tag detection from farther distances, which is something we struggled with a lot on some of our farther shots in auto. Yes, absolutely. So we're running our 2 instances of Photon Vision on 2 orange pies that are in the robot. And we had some large issues with the buck converters that we bought, where the voltage of the battery would dip too low as we ran too much current through the robot. And that would actually cause the pies to drop below their minimum operating voltage and quickly restart. So we switched to using portable batteries that we store on our robot and plug in to the pies to power them directly, which has been a lot more stable for us and hasn't caused us any dropouts or anything like that.
Awesome. Looks like we have a lot of fantastic software solution. This is a top tier team when it comes to software. Mechanically, they're incredible as well. I mean, at the end of the day, this is top tier robot is what I've seen at the Michigan State Championship so far. Incredible performance from you guys. I wish you the best of luck the rest of this weekend. This is Carter with First Updates Now, signing out.
This video on fun is brought to you by viewers like you and also in partnership with the following. AndyMark is your one-stop shop for all your robotics competition needs. Celebrating 20 years of quality robotics parts and superior service, AndyMark employees have over 200 years of first-team experience. From mechanical and electrical products to tools and hardware, head on over to andymark.com for high-quality and affordable solutions.